All right, so this is for Pre-Calc 11, Chapter 2, Section 4, called the cosine law. It says here, for right triangles, the trig ratio, sine, cosine, tangent can be used to find unknown sides and angles. For oblique triangles, sine law and cosine law must be used. So just to remind you, SOHCAHTOA is only for right angle triangles. If you don't have a right angle triangle, then you use the sine law or cosine law. It says here, as we've discussed before, an effective way to work with oblique triangles is to imagine the angle and the opposite side as partners, or what's called corresponding. Thus, angle A and little a, angle B and little b, angle C and little c are partners, or what's called corresponding sides and angles. It says here, in order to use the sine law, we must know one full set of partners and half of another set. If you only have half of each set, the three partners, or at least two of which are sides, then you must use what's called the cosine law. The cosine law is used when you have two sides and an angle between them, side, angle, side. And the cosine law is also used when you know the lengths of all three sides. So side, side, side. All right? So this example here says here, for each oblique triangle, state which law you would use. So x, y, and z. Notice that they're all lowercase. So the best way to draw it is lowercase. This will be angle x, angle y, angle z. So little z would be 32. Little x will be 30. And then little y would be 28. Okay, so because we have side, 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 automatically cosine law. Okay, now angle C is 27, side length A, side length C is 13. As soon as I see that, I'm going to go angle C is 27, length C is 13. Right away, you know, I'm thinking automatically sine law. So I'm going to go angle A, little a is 17. So we have a pair, right? And half of another one. So this is going to be sine law. Angle M and P. So here we go. I'm just going to draw the same triangle. This will be M and P. So little n is 16, little p is 14, and angle n is 41. Now, what's interesting about this is what's called side angle side. So if you know two sides and a contained angle, which means where these two sides meet, if you know the angle in between, it's automatically cosine law. Okay, so again, if you know two sides and the contained angle, it's automatically cosine law. So let's see if we can use this information. It says here, the cosine law can be developed by starting with oblique triangle ABC and drawing vertical lines H, angle B, side B, where H, okay. This basically goes on to prove the cosine law, which is something that we're not going to do. So I'm just going to ignore all that. But I will highlight, and you're going to need to remember these. Cosine law, notice there's a pattern. C squared is equal to A squared plus B squared. This looks so much like Pythagoras. But here's the kick. A and B, what you're going to do is you're going to multiply 2 times AB, cosine of the angle that you need to find the side for. All right, and if you take a look, all of them have the exact same pattern. A squared is equal to B squared plus C squared minus 2BC cosine angle A. B squared is equal to A squared plus C squared minus 2BC cosine B. They all follow the exact same pattern. Okay, so let's see if this is going to be kind of useful. Let's do example number 2. Says here, Cole wants to find the distance between 2 points A and B on opposite sides of a pond. She locates a point C that is 35.5 meters from A and 48.8 meters from B. If the angle at C is 54 degrees, determine the distance AB to the nearest meter. And so what I'm going to do is I'm just going to draw angle C. So here's angle C. It's 54 degrees. Here's A, here's B. And it says here, she locates point C is 35.5 meters from A, right? Point C is 35.5 meters, so this is 35.5 meters. And then 48.8 meters from B. And notice what we have is a side, angle, side. Okay, so what we're looking for is length C. Now the pattern works like this. Length C squared is equal to what looks like Pythagoras minus double the product, right? AB, cosine of C. All right, so A squared, well, that's 48.8 squared plus 35.5 squared minus 2 times 48.8, 35.5, cosine of 54. All right. I'm not going to show you how to use the calculator. I'm assuming that everybody has a scientific calculator. This is going to be 2381.44 plus 1260.25 minus 2036.56. This all works out to C squared is equal to 1605.13. And then, of course, we take the square root. C is equal to 40.1. And don't forget your units. Okay? All right. Again, when you have side, angle, side, right? Two known sides and the contained angle, it's automatically cosine law. All right. Next example. It says here, a triangular brace has side lengths 14, 18, and 22. Determine the measure of the angle opposite the 18-meter side to the nearest degree. Now, if you want to find angles, so it says your cosine angle C is equal to A squared plus B squared minus C squared over 2AB. Again, here's a pattern for this. Whatever angle you're looking for, that's what you're going to subtract. Times 2 times the opposite other angle. So here we go again. Cosine B, well, that means it must be A squared plus C squared minus B squared. And then 2 times these two, AC. All right, cosine angle A. Well, that means B squared plus C squared minus A squared. 2 times BC. Okay, so follow that pattern. All right, so let's see. In triangle ABC, oops, sorry, we didn't even do the problem. So let's go back. It says here 14, 18, 22. All right, so 14, 18, 22. So I'm going to draw a triangle. 14, 18, 22. And what we're looking for is, it says here, find the angle opposite the 18-meter one. Okay, so I'm just going to call this angle A. That means this is little a, this is little b, and this is little c. So if we're looking for angle A, that means cosine of angle A is equal to b squared plus c squared minus a squared over 2bc. All right, b squared is going to be 14 squared plus 22 squared minus 18 squared over 2 times 14 times 22. Now, if you do all the math, I'm not going to show it to you, cosine of angle A works out to 356 over 616. The measure, all right, every time we're talking about measure, you got to do the inverse. So cosine inverse of 356 over 616. All right, and that works out to roughly, roughly 54.7 degrees. And if you wanted to, you can round off to the nearest whole angle. So 55 degrees. Okay. All right. I think this is the last example. It says you're in triangle ABC. A is 29 centimeters, B is 28 centimeters, angle C is 52. Sketch the diagram and determine the length of the unknown side and the measure of the unknown angles to the nearest tenth. Okay, so what it's asking for is to solve, which means find everything about this triangle. So let's do this. I'm going to draw just your standard triangle. So I'm going to call this A is equal to 29 centimeters, B is equal to 28 centimeters. And if this is A, that means this must be angle A. This is B, this must be angle B. That means this must be C. So this is 52 degrees. Okay, so right away we have what's two sides and a contained angle. So I can say I'm looking for side length C. So I'm going to use this version. C squared is equal to, C squared is equal to what looks like Pythagoras minus 2AB cosine of angle C. All right, so this is going to be 29 squared plus 28 squared minus 2 times 29, 28 cosine of 52. Now, again, I'm not going to show you the math. I'm sorry, I'm not going to show you the calculator, but it works out to what looks like 1625 minus 999.8, which is equal to 625.17. That's C squared. Well, what is length C? Well, we take the square root, and that works out to roughly 25.0 centimeters. So now we've discovered this is going to be 25.0 centimeters. Now, how are we going to find the other angles? Well, now we have what is essentially a corresponding pair, right? We have an angle and a side. As soon as you have that, then we can find using the sine law, right? And so I'm going to solve for angle B next. So I'm going to use these two. How do I find that? So I'm going to use the sine law, and because I'm looking for an angle, I'm going to put the angle on the top. So sine B over 28 is equal to sine of 52 over 25, right? Make sure you put the angles in the numerators and the lengths in the denominator. So now we have sine of B is equal to 28 sine 52 all over 25. And when we're looking for angle, measure of angle B is equal to sine inverse of 28 sine 52 all over 25. Be careful with the brackets, everybody. Okay, I'm not going to show you the work. Angle B works out to 62 degrees. So let me shrink this back. I know this now becomes 62 degrees, and automatically we have angle A. So now what's measure of angle? Sorry, we have measure of angle C is 52. Measure of angle B is 62. Measure of angle A, well, that's just 180 minus 62 minus 52. Measure of angle A works out to 66 degrees. So sine law and cosine law can now be combined together to find or to solve all the angles of oblique triangles. But make sure that you do not have what's called the ambiguous case, okay? And if you're not sure what that means, you need to go back to the previous video in section 2.3. All right? I hope this makes sense.